After doing all of that again, notes work with the rotation theorem, the formulas, and the basic equation of a conic or of a second degree equation in two variables, we're given this right here. And the question would be simply sketch it. Nothing more, nothing less. Now, when I ask you to sketch it, it'd be nice to see the vertices if there are some. It'd be nice to see maybe the idea of where the focus are, if there are some. The directrix would be nice to see if this was a parabola, and an assortment of other possibilities. Again, get me as much information as possible. So, these problems are legitimately only formulas. Okay? The first formula we're going to use is the rotation theorem formula. The cotangent of 2 alpha is equal to a minus c divided by b. That's what I'm going to start out with, because if I can find my alpha, I'll know what this thing generally looks like, okay, or at least where it's sitting, what kind of plane it's sitting in. So, when playing with this, what I'm going to see is that a is going to be 7. Now let me go ahead and actually write all these pieces out. I have a is 7. My b value is that negative 6 radical 3. My c value is 13, and again, always use my a as x squared, my c as y squared. Now, my d and my e, my d regards to the x piece, and again, when I'm doing this, I'm keeping this in front of me, ax squared plus bxy plus cy squared plus dx plus ey plus f. So d and e, where d is the x term, e is the y term, are both zeros. And then my f term, okay, is a negative 16. Now, for this particular setup, all I really need right now is a, b, and c. So let's plug those pieces in. This is equal to 3 minus 13 divided by a negative 6 radical 3. That's going to be a, and if you can see that, let me zoom in a little bit. And there we go. Okay. So I have negative 6 divided by negative 6 radical 3. And the negative 6 radical 3, or negative 6 is canceled out. I'm left with 1 over radical 3, which is the same thing as, well, if I do this in a different light, this is tangent of 2 alpha is equal to just radical 3. Again, I'm changing this to be tangent and flipping this to be just radical 3. When does this happen? For what values of alpha does this happen? Well, I do know that tangent is sine over cosine, and that this would be a radical 3 over 2 over 1 over 2. And again, this is of 2 alpha. If that's the case, that means then, again, let me see if I can clear this up a little bit better. There we go. So then I have this and this. When do those particular pieces occur? What is 2 alpha going to be? Well, in this case, 2 alpha would be 60 degrees. If you look at the unit circle, let me go ahead and draw a quick one here. The cosine values are going to be decreasing from a value of 1, so 1 radical 3 over 2, radical 2 over 2, and 1/2. So it'll be right there at 60 degrees, which is the same thing as, again, pi over 3. So that means that alpha is really equal to pi over 6, or, again, 30 degrees. I now know my rotation, okay? My axes would be sitting here, but now at a rotation of 30 degrees, they're sitting here. And if it helps, alpha equals 30 degrees. This is my x prime, y prime. You can, again, ignore this set of xy axes. You do not have to draw it. Just make sure you draw it such that you give me this. That's alpha equals 30 degrees. So if you want to draw it like this, this is perfectly fine. Again, giving me this dotted line as where the old x used to be and where the new x prime is. Okay. Again, that way it's not as convoluted as this because there's four lines of axes. So I now have my alpha. My alpha here is good. What I now need to do is determine what kind of equation this thing is going to be. What kind of graph is this? Is it parabola? Is it an ellipse? Well, I don't know because I don't know how to deal with an equation that has this xy yet. We will come to the formula for that. But as of right now, what I need to do is determine what is A prime, C prime, D prime, E prime, and F prime. Again, there's no B prime because looking at this identity right here, again, this theorem, this, under the correct transformations up here, changes to this, where there is now no B. There's no XY term, because that XY term is being taken care of with this rotation. Again, with this rotation, that B is being dealt with. So, I need to find out all these values. Well, for me to find those values, I'm going to keep this thing real nice and close because all I'm going to do is plug in values for this. Okay? That's all I'm doing is plugging in the values appropriately. Well, I'm going to start with the easiest one. F prime is supposed to be equal to F. So F prime is negative 16. Next, let's go through all of the other values. My E prime is equal to a negative D sine alpha plus E cosine of alpha. Well, both D and E are 0, so my E prime is going to be 0, because it's going to be 0 times this thing plus 0 times this thing is all equal to 0. Likewise with the D prime. Okay? Let's talk about C prime. C prime is A sine squared alpha minus B cosine alpha sine alpha plus C cosine squared alpha. So I have to go ahead and plug in the alpha value, 30 degrees, as well as my A, B, and C values. So let me very carefully do that. My A value is 7. I'm now going to have the sine squared of 30 degrees. Let me move this over so you can see the rest of it as I write it. Again, plugging it into here. Minus a B. Minus my B value being this negative, so it's plus 6 radical 3. Times the cosine of alpha sine alpha. Now I'm running out of room on this paper, so I'm going to move this down, and I'll write it down here. C prime is equal to. It's the 7 times, and actually let me just skip all this extra junk. What is the sine of 30? The sine of 30 will be 1/2. Okay, so I'm going to change that. This is 1/2, and because it's sine squared, plus, again, minus the negative radical 6 over 3. So plus 6 radical 3. And I'm going to multiply this by the cosine alpha, the sine alpha. Well, cosine of alpha is radical 3 over 2. The sine of alpha is 1/2. And then I'm going to have plus my C value, which is 13. Again, looking at this formula right here, plus C cosine squared of alpha. Well, cosine of alpha is again going to be radical 3 over 2. And I'm going to square that. So, when I do this, let me very carefully identify all these values. This is going to be 7 over 4, plus the radical 3's are going to cancel each other out to get me a 3. Okay, so I'm going to have 6 times 3, which is 18 on top, divided by the 4. Yes, we can simplify that down, and I will. Plus, and then this thing over here will be squared radical 3 is going to be 3. 3 times 13 is 39, and 2 on the bottom squared is going to be 4. Without simplifying this down yet, I might as well just, they already have common denominator, so let me add it all up. We're going to get 25 and 64 over 4, which is the same thing as, if I'm not mistaken, 1, is that 16? So that's my C prime. Okay, C prime is 16. Now notice this took a lot of trig work. Mind you, it's still just formulas. Okay, and we will put it all together here soon. Last thing I need to determine is A prime. A prime is A cosine squared alpha plus B cosine alpha sine alpha plus C sine squared alpha. Again, I'm going to very quickly go through that. I don't think we need to actually see that being happening. Okay, so very quickly I'm going to have, down here I'll do it. Let me draw some lines here to get out of my way. A prime is equal to, it's going to be an A, 7, times the cosine squared of alpha. Cosine of alpha is going to be the radical 3 over 2, and I'm going to square that. It's going to be plus my B value, so a negative 6 radical 3, times the cosine of alpha, sine of alpha. So those are actually going to be the same as these values up here. Radical 3 over 2, 1/2. And then I'm going to have the plus I'm going to go ahead and write it down here, plus a c value, which is 13, times the sine squared, which is going to be the 1/2 squared. So let me go through simplifying this thing. I'm going to have, this is going to be 7 times 3 is 21 over 4, minus, this is going to be over 4 again, but it's going to be radical 3 times radical 3, which is 3. 3 times 6 is 18. And then lastly, I'm going to have 13 times 1/4, so it's going to be plus 13 over 4. So, with that being done, what am I going to have here? Well, I'm going to have 21 plus 13 is 34. 34 minus 18 is going to be, if I'm not mistaken, 16. So this is 16 over 4, which is just 4. So there's my A prime. Now, what does all of these formulas mean? I'm going to zoom this out so we can see all the work that we've done for this. And yes, it has taken us about 11 minutes to just do this one problem. It gets easier because there's less explanation, and all you have to do is plug in the values. So I now have all of the values I need, okay, to write out the actual equation. So the equation is, and I'm going to write this up here, 16, is going to be, I want A prime x prime squared. Now what I mean by x prime squared, this is on the new set of axes after the rotation, okay, after the rotation. Now, if you don't write the primes in there, for this, I won't take off points. Okay, for this, I will not take off points. But in the future, in other classes, it would be absolutely necessary for you to have those primes in there. So, what is this equation? This equation is 4x squared, again, the A prime, x squared. We're going to skip the b, because there is no b. So plus my c prime, which is 16, y squared, plus, now I have my d prime, there is none, e prime, there is none, minus the 16. So I'm going to go ahead and just subtract 16 equals to 0. This is the equation that we have, and I'm going to go ahead and say it's rotated 30 degrees. So I don't forget that that piece of information is there. Well, this actually isn't that bad. If I get it equal to 1, then I'll have what looks like an ellipse. So let me go ahead and do that. I'm going to add 16 to both sides. I get 4x squared plus 16y squared is equal to 16. I divide both sides by 16. That gives me 1 is equal to, this is going to be 4 over 16, which is x squared over 4. Plus this is going to be 16 over 16, so y squared over 1. Now, what that means is that in the new y-axis, I have a distance of 1 away from the center, and I have a distance of 2 away from the center on the new x-axis. So, if I do this appropriately, I'm going to put this dotted line here, say that this is 30-degree rotation. In the x-axis, I have 1, 2, 1, 2. Those are my endpoints. And in the y-axis, I have 1 and 1. Those are my endpoints. Connecting those dots is the ellipse I'm looking at. That actually completes that problem. Okay? I will actually do the next problem in the next video, and I will go through it in a relatively quick fashion. Again, utilizing all the formulas, doing all the same stuff. I'll do a lot less explanation. So, again, be very careful with these, but all in all, they're just formulas. They are just formulas.